Hello friends, welcome back to another session. In this session we will start Apache Kafka. In last session we have already completed our RabbitMQ course. If any point or any topic we have missed, we will see that later also when we will learning and going through the application development model like microservices and Spring Security and DevOps. So we will learn all those whenever we will come to know that topic. But generally, almost we have done in our last session. Next, we will start Apache Kafka. So Apache Kafka is also similar to RabbitMQ. It is similar to our RabbitMQ. So first we will see the definition of Apache Kafka, then we will see the installation, and after that one we will get started with our coding side. So a Kafka, generally we will call it as a Kafka only, not Apache Kafka. Apache, because it is given by Apache, the license is provided by Apache Kafka. Now it is owned by Apache Kafka, but initially it was developed by LinkedIn in a Scala programming language, and now it is one of the top level project of Apache ecosystem. Apache ecosystem has providing so many projects like Apache Maven, Gradle, Apache now providing Tomcat, Apache Maven, Gradle, or we have seen so many other projects that is provided by Apache. Even NetBean is also taken by Apache only now. Previously some NetBean is taken by some other company, now it is Apache NetBean. Similarly, so many projects is provided by Apache ecosystem. So Kafka is one of them. Okay, so Kafka is a distributed event streaming. Now what is event streaming? Similar to RabbitMQ, whenever we are publishing a message to exchange will send the message to queue, and whatever the consumer is consuming from that queue, it will automatically trigger. You don't have any control on that when this message will be triggered. Whenever message will be published to a queue, automatically the listener will start consuming that topic and will do the required operation, whatever operation we apply on that. So similarly, Kafka is also a distributed event streaming message publish or subscribe distributed commit log and open source platform. So in short, we can say that it is a distributed event streaming pub sub model open source platform, and it's developed by J. Creeps, Neha Narkide and June Rao, and handed to Apache Foundation in 2010. Apache handed over this project. Okay. Apache Kafka is a high scalable and reliable message storage system that is designed to handle a large amount of real-time data generated by many applications, providing high availability with no single point of failure. Now what is event streaming? As we have already discussed, whenever the message will be published to exchange will send the message to the queue, and whatever consumer is consuming from the queue, it will automatically trigger. So that is event streaming. Event streaming is a practice of capturing data in a real time from event source like database, sensor, mobile devices, cloud services and software application in the form of streams of event, storing these event streams durable for later retrieval, manipulation, processing and reacting to event streams in real time as well as retrospective. Okay. That's the general meaning of event streaming. Use of streaming event, where you should use this Kafka, where you should use in process of payment and financial transaction in real time, such as stock exchange, bank and insurance, to track and monitor car, truck, fleets and shipment in real time, such as the logistic and automotive industry, to continue capture and analyze sensor data, Internet of Things device and other equipment such as factories and wind pack, to collect immediately react to consumer interaction in order such as retrieval, hotel and travel industry and mobile application, to monitor the patient and hospital care and predicate changes in condition to ensure timely treatment in an emergency, to connect, store and make available data produced by different division of a company, to serve as a functions for a data platform, event driven architecture and micro services. So generally how where we are using in our application, where communication is happening offline, we don't want to wait user to sit and watch the process, so that how much time it will taking. No, that you do in a backend. You don't need to wait to user, you don't need to put user into a waiting state so that user will waiting and do. No, similarly if you are placing order, so when you clicking on place order, you no need to sit in the front of system and just you display a message to user, your order is placed. Later on you are processing that message, that order backend, in backend. So that is the best example of use of Kafka and RabbitMQ. Now streaming platform means that Kafka combines three key capacities so that you can implement your use case for event streaming end to end with a single battle testing solution. One is publisher. Who is publisher? Generally it is a writer or sender, and subscriber who read the stream of event, including continuous import, export of a data from the other system. So this just is a pub sub model. What is pub sub? Pub means publisher, sub means subscriber, publish and subscriber model. Who is publisher? Who is generating the data? Is a publisher. In our RabbitMQ also we have created two applications. One is publisher, another one is a subscriber, or you can say that producer and consumer. So that's a pub sub. So we will create a topic like we will create an application like publisher, another one subscriber, like that we can take. So that is a pub sub model. Just one subscriber will be there that will be consuming the data from the topic, and another one that will be writing that message to topic. There will be only topic. Okay. To store streams of event durability and reliability as long as you want. Suppose I want the message to be stored in Kafka for 30 days, I can do. But what happens in RabbitMQ, whenever it is delivered, message is delivered, it will remove from the Kafka server. That is a default setting. That is a chances that we can configure that timing in our using our configuration dashboard, like how much time the message should stay after publishing. Whenever I published, message should stay for 10 days, 15 days, 13 days, something like that, or it should be removed immediately. But in Kafka what happens, there is some default limitation, default numbers of days. For that much time the message will stay in the Kafka server. After that much time of data, like 30 days, it will remove from the Kafka server also. So that why this approach has taken in a Kafka, to store stream of event durability and reliability as long as you want, so that in case of some system failure, or if you want to retrieve the data, you want to take the backup of a data, last 30 days data, last day data, there then you have an source of data, so that you can look for the data in that one and you can grab the data. Okay, to process a stream of event as they occur and retrospectively. Okay, another one is now here some of the things. What is message? Some points that you need to remember. What is the terms that we use in what is message? Simply if you say message, what is message? It's nothing but a record, or you can say that it's a data that has to send. That is a message. A message is an atomic smallest unit of a Kafka, unit of data of a Kafka. Simply, the message can be in a simple string. Message can be a user custom defined data type, such as in the RabbitMQ we have taken the example of order or user rating. Order will have an order detail and order items, list of order items, and user rating will have some fields like user ID, book ID, user rating, when it is given the user rating date, something like that. So that is nothing but a message. The data, you understood here, the data or record that we are transferring, we are sending, called message in Kafka. It's similar to RabbitMQ. In RabbitMQ also we call this as a message only. What is topic? It's like a table where you will store the data. That is a topic. In RabbitMQ there are some other source where we will store the data, where we will publish the data, like exchange. In RabbitMQ there is exchange, and exchange will be binded to queue, and that queue will transfer the data. A queue will transfer the data, but in Kafka there is no exchange, there is no queue, no exchange, no queue, just topic. That's it. One topic is there. So that we will publish the message to topic, and from the topic only we will consume. So that is a topic. It's like a table, or it's like a source of a data where the data will be stored for particular days, for how many days you want to store. That's a topic. There is a no exchange, no queue, no channel, nothing like that. In Kafka, exchange is there, and further exchange has a type like direct exchange, fan out exchange, header exchange, or topic exchange. But here only just topic is there to store the data, and that from the topic only consumer will consume. But in case of RabbitMQ, consumer will not consume the data from exchange. Either we are publishing the message to exchange, but consumer is not consuming the data from exchange. Consumer is consuming the data from queue. But here in Kafka, a publisher will publish the data or publish the message to topic only, and consumer will consume from topic. So that is a pub sub model. Pub sub model we will see point to point and pub sub model. What is that? Next is partition. Partition means Kafka can be running in a scalable mode, like more than one places your Kafka can be running. So you want to do partition. Partition is an analog to shared in the database, and the concept of behind Kafka scaling capability. Like if I want to scale means I have a two Kafka server, three Kafka server. So that is a partition. So in which partition the data is stored? So that is nothing but a partition. Okay. Fine. Now next feature of Kafka. Kafka is an open source simple distributed messaging system based on pub sub model. That is the one feature. A Kafka is an open source simple distributed messaging system based on pub sub model. It provides high reliable and fault tolerant data pipeline between various system and application streaming real-time data. Kafka allow publish, that is a write, and subscriber, that is read, to store and process the live stream of a record. It provides a set of programming API to create custom producer and stream a consumer application. Kafka can run either on a single server or can be in a distributed also. That is a cluster, Kafka cluster. With the help of Zookeeper, we can handle that one. Zookeeper we will learn later. What is Zookeeper? That is another scaling tool where we will scale our cluster. Zookeeper. Okay. What is pub-sub model and what is point-to-point model? Point-to-point, the communication to one-to-one communication. How RabbitMQ supports both. RabbitMQ supports both pub-sub model and point-to-point model. Can you tell me what is point-to-point model with the demo? Can you write me in the comment section? What is the pub-sub model and what is point-to-point communication? From that one, what we have studied so far. So far we have studied Kafka, definition of Kafka and RabbitMQ course. So from that RabbitMQ, if I ask you what is point-to-point, what is point-to-point communication, one-to-one communication, what is that? So point-to-point is nothing but one-to-one communication. One-to-one means there is a one exchange and one queue. So from exchange to queue, so from the queue you can publish, you can consume the data. So that is a point to point, because there is a only one publisher and one subscriber. But in pub-sub model, subscriber can be many for the topic. You can write n number of subscriber and the data will be sent to the multiple subscriber or consumer. So that is a pub-sub model. Only Kafka supports only pub-sub model. It does not support one-to-one. There is no way to configure like one-to-one. How will you configure? There is only one exchange and one queue. That type of concept is not there. One queue can send them to many. It depends, but one-to-one is also possible. But in Kafka, one-to-many, it can happen only in Kafka because there is no concept to bind this one. Okay, so here is a difference between RabbitMQ and Kafka. The major difference, later also we will see some other. Supports both message pattern like point to point and pub-sub model. Both RabbitMQ supports both, but Kafka supports only pub-sub model, publisher and subscriber model. Does not gives guarantee the order of message delivery. Does not gives the guarantee of the order of message delivery. Like in a queue, if there are 10 message, or if you have published this one message to a Kafka, is it guaranteed that it will delivered in the same sequence? No, it might be delivered after later also. Doesn't guarantee that message will be delivered in the same sequence how you have published. But Kafka gives the guarantee that message will be delivered in the same order. Okay, RabbitMQ has itself a functionality of scaling. If you want to scale the RabbitMQ server, then RabbitMQ server itself has that functionality, so that you can use to scale the server. But in Kafka we need to use Zookeeper. Zookeeper is used to scale the server and external service, and Zookeeper is an other service. So that's why Zookeeper, we need to learn Zookeeper also. At least basic of Zookeeper we will learn the later, but you just understand Zookeeper is used to scale the Kafka, but RabbitMQ has its own scalable functionality. Okay, RabbitMQ support pub-sub model with channel. RabbitMQ supports pub-sub model also. Point-to-point model, how it is point-to-point model supporting? Using exchange. RabbitMQ supports point-to-point model using exchange and queue. But if you want to support pub-sub model in RabbitMQ, then you need to use channel. We have not seen that one because Kafka is the better in performance. Kafka is better in term of performance as compared to RabbitMQ, because for pub-sub model. Generally in application development, pub-sub model is mostly required, but yeah, for other reason RabbitMQ also using. So for pub-sub model we need to use Kafka. We can do the pub-sub model using in RabbitMQ using channel. We'll see that later if time permit. how we can create channel, how it is happening. But currently Kafka is better in term of performance, so we are using Kafka designed specifically for PubSub model, that's why. Next, message will be removed from the queue once delivered. We have seen this one. So far we have seen the basic configuration, the default configuration, sorry. Whenever the message is delivered to its consumer, it will be removed from the queue. But in Kafka, message will stay in a topic even if message is delivered to consumer for a long time, at least. Okay, so this is all about the Kafka, introduction of a Kafka. Okay, in next session we will see the installation of a Kafka. Okay, so that's all in this session. So please subscribe our channel, ask your doubt in comment section, so that is also motivate us, so that we can deliver you the best content and you can do your learning process very smoothly. And please make a financial support also. It's a very humble request for all of you. Please do your financial support also. Okay, thank you and have a nice day. We'll see you in the next session.